We continue with our discussion on air-jet texturing with some of the process parameters which may be affecting the properties. We will consider them. So, in the last discussion we have had, we did talk about various methods of characterizing air-jet textured yarn. Instability and physical bulk are the two more important properties. Physical bulk is because we call it bulked yarn, so that one something which must be measured. Then other things like shrinkage, surface characteristics, tenacity, modulus, and we did discuss something on the instability and bulk, the effect of overfeed. We carry on the discussion further on other process parameters. Some variables, not every one of them we are discussing at the moment. So, last time we talked about the effect of overfeed on instability, bulk and some of the surface characteristics. And we found that from the point of view of surface characteristics, the size of the loops as well as the core diameter and the number of loops formed with the increase in overfeed is been seen and expected, and that would have a consequent effect on instability and bulk. So, they are in a way related. So, effect of overfeed on hot water shrinkage. So, let us assume that in hot water at the temperature that we are talking about, we expect some shrinkage to take place, because it is a, let us say, it is a thermoplastic yarn. If it is not a thermoplastic yarn, the temperature may not affect, but the water may affect. So, let us say if we look at just the shrinkage, because we said either it is because of relaxation in the molecules or because of swelling. Just to take the discussion a little further, when let us say hydrophilic fiber, let us say viscose, swells, and what happens to, let us say this is a staple fiber, what happens to its dimensions if you put it in water, the dimensions of the fiber. Dimensions means the diameter, the length of the fiber, viscose or a cotton. What do we expect? The diameter would increase. Diameter would increase and the length decrease. How many of you have done any such experiment in lab, that you put a cotton fiber in water, measure its dimensions before and after this swelling process? Have you done any experiment? Have you observed, or it was just a common sense that you are using? You have observed. What have you observed? That the length shrinks, the fiber shrinks, diameter increases. Is that what you observed? Consider something like a balloon where you are filling the water inside. What do you expect? Diameter will increase, the length will reduce. So, this swelling process in hydrophilic fibers is not something which is like a fixed volume stuff. You can either, the volume remains constant. If the situation is that the volume remains constant, then change of one dimension would change the other dimension. But in this case, when the water enters, starts separating the molecules, distance between the molecules start increasing, it starts making hydrogen bonds, separation increases, and by doing so molecules are in all directions also. One actually sees increase in diameter as well as the length. How much is a different story, but if you look at a fabric of a hydrophilic material or a yarn made from hydrophilic material, then what do you observe? That can shrink. That is what we consider as shrinkage due to swelling. It happens despite the fact that the length of the fiber may have increased, the diameter has increased, but you still see a shrinkage of the assembly. Why does it happen? Why does it happen? Why do we say that the cotton fabrics shrink? So, do a sulfurization treatment or do any other kind of thing so that the fabric does not shrink in water. Anyone? Have you heard it for the first time, or you think you have heard before and arguments? But you know, cotton fabric shrink, no doubt about that. So, what do they shrink? Say if this is the kind of your structure warp weft, and if the diameter of this increases, then the other fiber has to traverse a longer path. From where will it get the extra length? From where? So, you just shrink. So, this is something related with shrinkage due to swelling. The shrinkage due to swelling is not such a issue in hydrophobic fibers, because they do not absorb moisture and they do not shrink. For these type of material, the shrinkage due to relaxation of stresses within the fiber or in the assembly of fiber that you make would make them relax, and so that may lead to shrinkage. For example, thermal shrinkage. So, the hot water shrinkage therefore has more to do with relaxation, okay, that if you take a polyester fiber, put it in an oven, it will shrink in length, all right. If it shrinks, then whatever happens. So, we have two situations where a fiber actually shrinks, and in the case fiber may not shrink, but still shrinkage is seen. So, in any case we have a hot water shrinkage, like you do an experiment with an air jet textured material and which have been prepared at different overfeeds. Then what we want to know is what is likely to happen at all. Yep. So, let us say I am looking at the possibility of working on the hot water shrinkage. So, before you answer this question, obviously you know the property of the fiber. Let us say we are talking about polyester to begin with. So, we are justifying hot and water, but it is a shrinkage process. So, if this is a polyester air jet textured yarn where different overfeeds have been used, do we expect anything to happen in this? Because of overfeed? It's a thermoplastic fiber, so hopefully fibers will shrink. The fiber shrinks because of its property, thermoplastic. But now the same fiber or filaments have been prepared in energy attraction machine with different overfeeds. We have seen what happens to overfeed and instability, what is the relation between the bulk and the instability, that kind of thing was one of the things which we understood. Now we won't measure the same thing, the hot water shrinkage. You think it's going to happen? Could make any difference? So let us see, we have whatever. So hot water shrinkage versus overfeed, all right, hot water shrinkage versus overfeed. So answer, effect of overfeed, no, would shrink more, would shrink less, even if we forget about the trends and so on and so forth. Fiber is same. Condition of test is also same. So, how many people believe that there will be no change? Because of overfeed, not because of that putting the yarn in the hot water. Yeah. How many people believe there is no change? Yep. One person dared to say something. All right. How many people believe the shrinkage will be more? So, if you increase the overfeed, one more person thinks that the shrinkage will be more. How many people believe the shrinkage will be less? All right, so there is one more. So basically in the class there are 3 people who have 3 different opinions. Others probably do not know. Very interesting. So 3 possible answer which I have given. I mean, if you had instigated other guys, so maybe 4th, 5th answer could have come, I don't know, whatever. So divided opinion, but we must justify. The one who believes there is no change, why do you believe that? Yeah.
There is less stress in the yarn because loops are bigger because of overfeed.
Yes. So there is no change. Okay.
Stress is less,
Stress is less.
so there is no relaxation. So there is no shrinkage.
So no relaxation. That means hot water is not going to play any role.
Relaxation is there, but not because of overfeed.
Not because of overfeed. Okay. So it's maybe something is happening, but it may happen to any of the yarn, but it has nothing to do with overfeed, right? So because property is same, they will just shrink. Good. So the people who believe there will be more.
Because in case of overfeed, extra length will be there, so more time will be there for subjecting the thermal shrinkage, so it will lead to
Time. We are not giving more time.
not more time, but length is extra length is there, so shrinkage will be there, more shrinkage.
All right. And those who believe less?
Due to extra yarn, extra overfeeding, extra yarn in.
So because there is an extra yarn, therefore shrinkage will be less. Shrinkage will be more or less?
Less.
Less. So anyone wants to argue with this argument, these arguments? I mean, now there is answer and there is argument, or everything looks good. You ask this question in examination, whosoever feels like whatever they feel, they will like the answer. And they are all justified, right? That's like a political statement. You see, the only thing that is constant is, let's say we said it's a thermoplastic fiber, and when you heat, if it has to shrink, it will shrink because the fiber is the same. So fibers will shrink, there should not be a doubt. Fibers will shrink. That should not be a doubt, because fibers are supposed to shrink at a high temperature. If they are shrink, or it will be the same. We are not looking at assembly. We are not looking at a fiber. We are looking at assembly, where one of the yarn has very less overfeed given and the other yarn has been given more overfeed. So, let us say if we want to answer this question again by saying or recalling what happens to the instability of the yarn when you increase the overfeed. Instability increases, and increases sometimes exponentially. And why does that happen? Because there are loose connections, entanglements are not good, and what it means is OOP can open. What it means is inter yarn friction should be less, otherwise they will be compact, they will not open. So, the basic property is not changed, distance is changed between the thing. Now, in such situation where the overfeed is high, structure is very open, put it in the hot water, fibers will tend to shrink. Now, the question was on yarn. So, would you like to consider your options now based on the old information recalled? No effect. So, let us say we take the poll again. Now, we are more wise. We are more wise. So, how many people now believe no effect? So, the problem is only one vote. The person, the earlier one is gone. No, there is one, two. And the people who believe that is going to be increasing, एक ही है, nothing has changed. No, there are one more. And the less is changed. This guy has gone here. All right, so it's not helping. It's not helping. The answer has to come from the fact that when in a cotton fabric, despite the fact the fiber was swelling, length of the fiber may have increased, but the fabric was shrinking, the yarn was shrinking. Why? If in similar situation a fiber actually shrinks. So, in a situation where they are closely held, and if within the core there is a shrinkage of the fiber, and because they are close, so interfiber friction would ensure that the others which are nearby also follow the path. The ones which are in the loop, part of a loop can shrink. It is not going to change the length of the yarn, because loop is shrinking, so what? But if it is tighter material here, lot of entanglements, and if this one wants to shrink, the other cannot refuse. Versus a situation, a sliver instead of a yarn lying in some hot oven, every fiber wants to shrink, but the one which is shrinking cannot force the other one which is near somewhere to also shrink. So, it shrinks its own ways. Let us say you have a situation where there were fibers which were overlapping, fibers of some length in a sliver, all right, all of them shrink. So, the length becomes smaller, they may overall, this one becomes this one becomes slightly this one becomes slightly this, but the over length may not change at all overall. When they are free, so they just do their job, they do not bother, they do not take the assembly along with it. But when they are tighter, all of them must respond to anyone which changes. Either they do not allow it to shrink, I can't shrink, you don't shrink, or let us all shrink because shrinkage means again lower energy. And so, interestingly, that if you increase the overfeed, the hot water shrinkage increases. No, 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 sorry. No. What does happen? Decreases. Okay? Interesting. What has hot water shrinkage to do with the overfeed? And you say, oh my God, there is a change. That means whenever you are in an assembly form where each element is dependent on what happens to the element, because they were twisted together, they were brought in close together, one of them independently cannot move by itself, and so the total effect therefore is that all of them will get affected. If all of them are shrinking, then obviously they keep shrinking. That is the best way for them to survive. So, this can actually happen, and that is interesting. Good. This is some results from one of the papers, Kothari et al., on mechanical properties of air jet textured yarn. Effect of overfeed. So, let us say they have increased the overfeed. One is a parent yarn. There are 3 different conditions of overfeed, and you try to work around. So, one thing which you can notice is the parent yarn has higher tenacity and the textured yarns have lower tenacity. So, textured yarn can actually be very bad, because most of the yarns are lying everywhere, they are not contributing. So, this can happen. And because they can open also, maybe by the time there may be some little experimental stuff, but because of slippage you can have some amount of extension, starting with a low extension and go to higher extension. But the modulus definitely goes down, because when you extend, slippage or other things become more dominant, and so a parallel bundle of the same filament resists more deformation, but very highly unoriented kind of thing, which you keep on increasing the overfeed, then they just may lead to more slippage. So, the initial thing would may appear that it just slipped, very less resistance. So, modulus can go down. So, that means a process which actually has no effect on morphology can also affect tensile properties, right. You have not damaged any fiber, but because fibers in their longitudinal direction or the direction of the axis are stronger than any other direction. And so, this is an interesting type of a thing which we see on air jet texturing, which is supposed to be a simple mechanical process, not doing anything to anything. So, we look at the other important process control parameter, which is the pressure, which you can change. Obviously, we are expecting that the other parameter, let us say the overfeed is constant, the machine speed is constant. So, we can increase the pressure at will. Let us forget about the cost. So, what do we expect would happen in general? Very low pressure versus high pressure. If we go and if you want to understand, would it increase or decrease? First, let us settle that down. Instability will? Good. So, there should not be any confusion and it cannot keep decreasing when you almost have a choked thing, completely compact system, and after that you keep increasing pressure, may not much of a difference, right. So, it is opposite to the overfeed. So, in some sense you know, well, if there is a problem there, I can increase the over pressure, and so I can control instability in some way or the other, right. So, even if the same overfeed keep, that means if you have more overfeed, you want more larger loops to be created and everything kind of things, more bulk to be created to begin with, then you try to do something with the pressure also to balance, right. So, pressure can do entanglements more and can give you a better thing. Of course, cost is increasing now. In overfeed, only the length of the yarn will keep shrinking. You have 30% overfeed, length of the air jet texture yarn will less by 30%. That's cost, but you can charge maybe. Here also you will have to charge. The cost will increase because of the consumption. Higher pressure, higher consumption also is there. No confusion here, right. Effect of pressure on bulk. Right. General initial response. Obviously, we are assuming overfeed is constant. Everything else is constant. So, increase or decrease. I am sure the third option called no change you will not like to exercise. Good. So, there are only binary stuff, either here or there. So, who said increase? Yes. Why would you think that should increase?
Sir, bulk is defined as a density, and if the pressure is more, the loops are just the loops are take some less area, so that's why bulk are increasing.
Area is less, bulk is increasing. This is some interesting thing. A specific volume and not the density, right? The bulk. Okay. Yeah.
On increasing pressure, there are more entanglement order
Right.
and more stability of loops.
That's called the instability is reduced. We have agreed.
Yes. Then
Now bulk.
there are more amount of yarn entangled. Then we set bulk increase.
All right. Okay. Other decrease, anybody believes in decrease? Nobody believes in decrease. Right? Very nice. Before that, before we come to some conclusion here, let us go a little further. So, you can answer these questions only if you have some information on this same overfeed, loop size and loop frequency. Let us look at these things. What will happen to the loop size and what will happen to the loop frequency? When you have more pressure, what would happen to the loop size, average loop size? So, will it increase average loop size? It will decrease. And the loop frequency will So, this is not going to follow the results of the overfeed, because here length is same, excess length available for loop formation is same. So, if more loops are formed, then the average loop size have to go down. So, they are going opposite, right. The core diameter can only either remain same or come down little bit, because becoming more compact. So, now what is the response on the bulk having some information on this? Now we go back here. Yes? Decrease? Increase? Decrease, right. So, how soon we want to change our opinion, it just depends on who is discussing, right. Okay. But in this case also the bulk increases. The increase in the bulk is not to the same extent as the you saw with the increase in overfeed. So much of yarn is available to do that. Here the length of the yarn available is constant. But what happens is, if you form large number of smaller loops versus small number of larger loops in the same length, you can produce small number of larger loops, which can happen at low pressure, and at high pressure you may have smaller number of larger number of smaller loops. Let me repeat again. At high pressure, larger number of smaller loops can be produced. The response of a loop to any stress in this direction is different. The smaller loop resists deformation. And how have we measured the bulk? We have wound it on a package. So, if it is a larger loop, they just become flat. They will not contribute except probably the thickness of the diameter of the yarn. But this, when you compress, would like to keep the thing away based on the tension on the yarn, on the package. So, here you are actually getting both the properties better by pressure. Okay. In the overfeed case, bulk was increasing, instability was decreasing. But in this case, instability is decreasing, which is good for you, and bulk is increasing, which is obviously good for you. But you must remember, this is not going to be the increase in bulk equivalent to what you will see in the case of increase in overfeed. But reason is different. There you have more length, more numbers, more everything, and therefore you are increasing. Here the number versus the average loop size is related in opposite ways. So, this we have just discussed a few minutes before. So, the tenacity again you see goes down compared to this. Extension also is less still, because slippage also can be less, and the modulus is following a different route. The more entangled it is, less would be slippage, and with the increase in the pressure, the modulus is increasing, of course, still less than this, right. So, these two things, and therefore, people would like to observe microscopic thing to just understand why something happens. If everything follows the common sense, nobody would do research. So, when you find that there is common sense not working, then we must improve our common sense, and that is how we improve our common sense. Suppose now we understand what is bulk and what is overfeed. Somebody has done some experiments, somebody has done some other experiments, increasing this, increasing that, and taken all the data, and after that you say, well, here I am putting the value of bulk, and here just one sec, what I am doing now, instability. This is what I want to plot, a generalized curve, irrespective of what I have done to the yarn. Many yarns have been prepared, see the bulk, see the instability, see the bulk, see the instability, and then try and plot them. What do you think would happen? Quick guess. If bulk increases, right? So, in general, if you keep on increasing the bulk quite a lot, you will get keep getting a bad yarn. Of course, if you just keep increasing the pressure, maybe you are in a different zone, but if you overall keep on increasing the bulk, because I want a bulkier yarn and still more bulkier yarn, then you would find that instability will. After all, what is happening? There has to be entanglement. Entanglement means something will come closer, sizes will come down, and so on and so forth will happen. So, overall, this is how, if a general, without worrying about what have you increased, what have you decreased, how many things, if it is the same kind of example, this is what we can expect to happen. So, effect of heat setting. So, there is thermoplastic yarn, and you know what we are talking about is the air jet texturing has taken place, and now you are taking through a heater. So, in general, we expect when you heat set a fiber, what would happen? Two things should happen. One, length may shrink if you allow it to. Crystallization and morphology can change. Now, because you are actually getting a thermal environment. So, if we agree and remember the old thing that thermodynamically disorientation is possible, which means shrinkage, and crystallization is also possible, which means stability. Stability means further change in dimension will not take place easily, right? Okay. So, if you do the heat setting, because of fibers wanting to shrink, core diameter may also shrink, because anything which you are wrapping around will also make it compact, and so you may see core diameter may go down. You may like it or you may not like it. Loop size, it decreases because the free loop which was there can become this. Generally, you expect that. The loop frequency, why would the loop frequency decrease? Is only if some of the very small loops were here, they may just disappear. It got into the structure itself. Some of them may go. Okay. So, this may happen. So, what would happen to instability as a result of this heat treatment? Yeah? Decrease. No confusion? That is why we are doing it, otherwise why spend money? The bulk compared to just before, We are not saying whatever yarn we had. Bulk also decreases because some of the other loops which were very small also contributed have gone vanished. Core diameter also shrunk. Core diameter has also gone down. And larger loops will become smaller loops also. They will contribute definitely, but some of them which were otherwise contributing are not contributing anymore. And the hot water shrinkage, obviously you are stabilizing the structure, crystalline content may increase. So, you have a stable structure. Whatever happened, happened. If you allow shrinkage to take place during this heat setting process, you have allowed. But now the final yarn which you get and test it is going to be more stable, because you have allowed all the shrinkage and relaxation during heating process. All right. So, final yarn is a stable yarn. It's stable because now it does not respond to hot water. What is the temperature of hot water? 80 degrees. And you would have done this at 180 degrees. So, there is no question of a smaller temperature doing large deformations in a fiber, right. Tenacity may not change significantly because the loops which were there have become smaller, they were anyway not contributing to tenacity. The one which were in the core, they were anyway tight, and now they become more tight. So, if they were lying flat or they were parallel, so they remain approximately flat or parallel or oblique, and so may not change significantly. Some disorientation which may take place in the molecular configuration because of shrinkage gets overpowered with so much of a disorientation in the macro structure that we have done. The macro structure plays more important role than the microstructure here, because you have seen in the false twist texturing, because of the amount of loss in tenacity was there, but not so much compared to an air jet texture yarn which is no change in morphology and still you can change lots. So, you actually, the other factors are playing much more important role also, and therefore does not change. Breaking extension can decrease because everything is in a different position, tightly thing. The one which are being stressed in a transverse direction are weak, so you can have decrease. Initial modulus can increase because now slippage are going to be much less, but obviously will still be lower than the parent yarn. Right? Interesting, right? So, theoretically a process which is supposed to be simple mechanical process or the things, you can actually see many kind of things happening at the end of the process. And so, it depends on how much stressed you are to optimize your properties versus the need of the customer. You are on a different ground, you should be. It is not easy for that matter, like whatever you want I can give you. So, let us see. In later part of the machine development, people said that let us wet the fiber little bit. So, in this context, why people thought was there was a lot of work being done on inter-yarn friction on the air jet texturing process. It was a belief that before any entanglement takes place, before any loop formation takes place, before one filament from one side goes to the other side, entanglement means this, starting on this side of the yarn, during this process go to the other side of the yarn. So, this intermixing, entanglement, etc., can be affected if the inter-yarn friction is high. Somebody wants to go to the other side because the friction is not able to go. And how much time do you have? How much time? Within that short period, everything has to happen. And if you can restrict that process by any means, then will not happen. A lot of papers were published how much spin finish to be given, which kind of spin finish to be given, etc. At that time, some people thought, if suppose I have a polyester yarn, forget the spin finish, I am wetting. Okay. So, they believed that the inter yarn friction could be less because a layer of water has been created between them and it just can just slip, right, slip. Sometimes you slip on a wet floor more than a dry floor, isn't it? How many people have fallen coming out of swimming pool? Right. So, on a wet floor you can slip more, that means the friction could be less because there is a hydrodynamic layer which has been created between two surfaces and a shear just happens. So, they said if suppose we do that, then maybe friction goes down and you can get a better yarn. Better means instability should be low, that is one of the reasons why anybody wants to do anything on edge texture yarn. And what did they find? Yeah, just by applying water, they could get better instability. And so, like eureka kind of a stuff. Oh my God, we found, reduce the friction, you will get something better. Well, very interesting. You will be surprised, so many people wanted to publish so many papers on friction. Everybody wanted to support the previous result, right. So, now another result, interesting, they got better yarn. Why? We will answer maybe when we meet again. Thank you.